أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Dear students, today I will explain to you page 9 and 10 of your science book. So open your books and come on page 9, please. It is quite clear now. Open your books and come on page 9, please. And today my topic of discussion is the vacuum flask, an example of transfer of heat energy. And at the end of this lecture, you student will be able to understand the function of the vacuum flask and to understand the transfer of heat energy in daily life. I hope so that at the end of the lesson, you will be able to explain all these things. Now come towards the topic, different shape of a vacuum flask. Okay, I will show you different shapes one by one. Okay, that you should keep in mind these shapes in your mind. These are the shapes of vacuum flask. So this is the first shape. This is what's so called bottle shape. Okay, you can see here, this is like a bottle. Okay, they have two layers, they have two surfaces, the outer surface and the inner surface. The outer surface is usually made up of a plastic or steel, and the inner surface is made up of usually glass. Okay, a vacuum is created in between the two surfaces. Okay, and a cork or a cap or a plastic stopper is placed over it. So this is the first shape or the earlier shape that use. Okay, you can see here that at the top a plastic stopper is placed there, the outer double wall metal or plastic container. Okay, and this is what so called the vacuum in between the two surfaces. Okay, this is what so called a silver surface double glass bulb, and this portion is what so called insulated support. Okay, you can see here these two, they are so called insulated support. Now come towards the second type of thermos. You can see here, and you usually observe this sort of structure in your houses. Okay, so this is another example or another shape of thermos flask or vacuum flask. You can see here these bottles, these are so common to you all. Okay, usually you should bring water from your homes in such flask. Okay, these are so called bottle flask also. You can see here, these are in the shape of a bottle, and the same structure they have as that of this bottle flask. Okay, so this is another type or another shape of vacuum flask. And come towards the last, these are so called plastic bottles. These are also considered to be the vacuum flask. Okay, but they are not good enough as to compare to these shapes, because they have vacuum and they can long lasting your colder liquids or hotter liquids. Okay, so these are different shapes of your vacuum flask. Okay, the vacuum flask is a thermos flask. Okay, they can also say thermos flask to keep drink hot or cold for hours. The flask has a number of fuses which reduces the rate at which heat flow in or out of. You can see here in this diagram, it will give you a complete idea about a vacuum flask or thermos flask. Okay, at the top, this is what's so called stopper. Okay, this is what's so called stopper, and below this is said to be gap with air removed. Okay, this is the gap between the two surfaces. This is the vacuum, this is the vacuum portion of this device. Okay, this is also called glass or steel wall, these two. Okay, these are double glass wall. Okay, you can see here these are two walls, and it will reduce the transmission or the radiation that can go in or out from the flask. Okay, you can see here in this shape that there are two walls. These are so called uh, silver wall, because the purpose of silvering these walls to reflect most of the radiation that will coming from outside. Okay, these are also called silvery sides, and this is the bottom, and these are so called the supporting part of the flask. Now the stopper reduce heat loss by convection and conduction. Okay, this stopper reduce the heat loss by conduction and convection because it is directly connected with the liquid. So conduction and convection processes occurs here, and it will stop the conduction and convection processes. The space between the two walls has the air removed, vacuum, so heat loss by convection and conduction is reduced. Okay, here a vacuum is created in between the two walls. The result of this creation of vacuum is to reduce the radiation process. Okay, because radiations do not require any medium for their propagation. Okay, so it will stop conduction and convection. If a vacuum is created there, automatically conduction and convection will be stopped there, because conduction and convection require medium. Okay, and to avoid radiations, it will silver this outer surfaces of the flask, okay, or the glass. The silver lining of the walls reduces heat loss by radiation. Okay, these walls are polished or they will be silvered. Okay, and the result of it that it will reflect most of the radiation that will coming from the outside. So it will be reflected, and as a result, the liquid that inside this glass will be quite hot or cold for a very long time, or for so many hours. An interesting information here for you. Okay, the vacuum flask was designed and invented by a Scottish. Okay, that scientist belongs from Scotland, so he should call a Scottish scientist, and his name is Sir James Dever. Okay, in 1892, for the first time, he invented, or he discovered, or he designed a thermos flask. Okay, and the thermos company was the first to mass produce a vacuum flask for everyday use. So that's why we should call it commonly that thermos flask. Okay, but thermos company was the first company to invent thermos flask. Some questions here for you. Test yourself on page 9. Okay, so the first question is, suggest why the vacuum flask is commonly called a thermos flask. Why it is so called thermos? Because thermos company was the first to invent or to design the vacuum flask. So that is why it is commonly called thermos flask. Okay. The second question is, explain why a vacuum flask can keep drinks cold as well as hot. Why? What's the procedure is? The reason behind it that no heat can get in or out of the vacuum flask. So that's why the drinks that should keep in uh, for a very long time, that will be hot or cold there. Okay, and what is the function of the silver lining in a vacuum flask? So the third point is the answer of this question. The silver lining of the wall reduces heat loss by radiation. This is the answer of the third question. Okay, and the answer of the second question is the second part. The space between the wall has the air removed vacuum, so heat loss by conduction and convection is reduced, and that's why the drinks that are hot will be hotter for a very long time, and that will be cold for colder colder for a very long time. I hope so that this thing will be quite clear to you all. Okay, and now come towards more about the changing states that earlier in this chapter you read about the kinetic theory of the wave particles behave during melting, evaporation, and condensing. Okay, so let us see what happens when some crushed ice is heated. Okay, this is a beaker. Okay, you can see here, and it have a lot of it have some crushed ice pieces. Okay, a thermometer is connected with it, and this is what's so called stir, because you can stir it to dissolve the or to melt the ice quickly. Okay, so this is an experiment, and we should perform this experiment. The ice is generally warm until it melts. Okay, you can heat it up. This ice cubes. Okay, and until it melts. The heat is then turned up until the water begin to boil. You should continue to heat them, and until and unless the water will become to boil. Okay, so the temperature is taken every 30 seconds from the start to finish, and it will give it and the idea will give us from this graph. Okay, you can get the idea from this graph. The graph shows the results of this investigation. Okay, so it will be from minus 30 degrees centigrade to 0 degrees centigrade. It will be in the form of ice. Okay, these ice will form of ice until all the ice are not melted there. Then the temperature will be quite same, because it will be at the same temperature at 0 degrees centigrade until and unless all the ice cubes will melt there. Okay, if all the ice melts there, then its temperature will be rising there, and it reaches to 100 degrees centigrade, and at 100 degrees centigrade it will start boiling. Okay, it will start boiling, and until and unless all the water molecules will be converted into steam. Okay, if it is converted into steam all, then again its temperature will be raised there, and it will be increasing from 100 degrees centigrade. Okay, so from this experiment, you can observe that at 0 degrees centigrade, the temperature of the ice will be remains quite the same until and unless all the ice cubes will be melted there. Okay, and if all the ice cube will melt there, then its temperature will be increasing. Okay, and it will start increasing from 0 to 1 2 3 up to 100 degrees centigrade. If it reaches 100 degrees centigrade, then it will start boiling, steam will coming out from the water, and the temperature will be quite 100 there for almost all the water molecule will be converted into steam. So that is what so called the uh, temperature differences between different states of the uh, matter or different states of ice into water into steam. Okay, so what does the graph shows? In first stage, the heat energy is rising. The temperature of the ice is up to 0 degrees centigrade, melting point. Okay, if all the ice melting, if all the ice, until all the ice melts there, its temperature will be quite 0 degrees centigrade there. Now come towards the second stage. This is what so called the second stage. Okay, ice and water mixture. This stage is so called ice and water mixture. At this stage, all the cubes are in ice form, in a solid form. But in this stage, you can see here that it is a combination of ice and water. Okay, so here there is a very little temperature rises, and the temperature energy is being used to allow water molecules to break away from their fixed position in the ice. The solid is turned to liquid. Okay, it will turning to liquid from solid to liquid state. This is the stage from which the ice converted to liquid or the ice converted to water. Now come towards the third stage. This is the stage where this stage starts where all the ice converts to water. Okay, or in other words, we can say that this is the stage where the liquid state will start. Okay, so the heat energy is rising the temperature of the water up to 100 degrees centigrades. Okay, it will give you 100 degrees centigrade. This stage will finish at 100 degrees centigrades, and this is what so called the boiling point. This point of the experiment is so called a boiling point, or this point of the water is so called boiling point, in which the heat energy should be raised to 100 degrees centigrade, and the water will be converting from this point to water vapor, means another state of the water will come, that is so called steam or gaseous state. Now come towards the fourth stage. Here there is no temperature rise. Okay, you can see here that the temperature is quite constant there for a very long time. You can see here the temperature is quite constant. This line, this straight line, gives you the information that in this state the temperature will be remains constant there. Okay, no temperature change will be occur there. Okay, so temperature will be constant here, and the heat energy is being used to allow water molecules to break free completely. The liquid is changing into gaseous state. From this state, it will starting
Yeah.
from gaseous state. Okay, now come towards the exercise. Describe what happens to particles, a solid, when it melts. So, who will give me the idea about
Sir,
this?
sir.
Raise your hands. Muhammad Ibrahim, you wanna answer this?
Yes, sir.
Mars is here to
Sir,
answer
it
the.
become liquid.
It become
Liquid.